Hey there, all you fine students in Science 9. It's Mr. Mechnick with a podcast on separation techniques. We are going to be using lots of different separation methods in class this semester to learn how to separate all kinds of mixtures. So these are some topics you should become familiar with and some of the tools that we will be seeing in class. To help you complete this, what I would recommend doing is filling out the separation method note sheet. This is posted on Canvas. So as I go through this, you can be listening for the physical property of matter that's going to be used during that separation method, and then the tool that we would use, and then give some examples to help you remember how that separation method works and some common examples. So to begin, we're going to be focusing on magnetism, filtration, evaporation, centrifugation, chromatography, distillation, decanting, and hand separation, to name a few methods that we're going to be using in class. So as you can see, there's lots of different types of equipment that we can use for separating different items. And it all comes down to the physical property that is necessary to separate a mixture. So the first one is magnetic separation. Obviously, this one's sort of self-explanatory. If the material that we're trying to separate is magnetic, meaning it probably contains some iron, some cobalt, or nickel, we can use magnets to separate them. So one of the common examples is iron ore separation. So when people mine bauxite and they grind it up and they crush it and they put it into a machine, there's this big separator drum that spins around, and as the ore goes past it, there's magnets on the one side that will actually attract the iron, and it will be able to separate the iron from the rest of the minerals mixed in with that sample. Other examples that use it: recycling facilities. So when they get their commingled recyclables, anything that's magnetic can be pulled out from that. So magnetic separation uses magnetism as a property. Another one that we're going to use in class quite often is filtration. So filtration can be utilized in a lot of different formats. We will be using funnels with filter paper to extract residues that can't pass through the filter. So as long as we have a filter paper that has a small enough pore size, we can extract a lot of different substances from that. The material that we're extracting is called the residue, and it really works on the property of particle size. So the size of the particle is what would work well to extract these substances. So if you think of the filter paper or even coffee filters that we use to make our coffee, it filters out the coffee grounds. They can't make it through the little tiny openings in the filter paper, and some molecules can. So if this is coffee grounds, these might be caffeine particles that can seep through into the coffee. Or if we're separating a heterogeneous mixture like sand and salt, the salt ions can make its way through, but the big sand particles cannot. So it works on particle size. So something that is fairly common right now that you hear a lot about in the news is using respirator masks to help filter out airborne pathogens like the coronavirus. So just to kind of give you an idea, a lot of different masks that you can buy at the hardware store or at Walgreens or at Walmart, they come with a ranking based upon how much of the particles in the air they can remove. So N85 respirators, which is the most commonly sold ones, removes 95% of all particles that are at least 0.3 microns in diameter. So that's pretty small, but one of the things that you'll realize is that COVID-19, the coronavirus, is actually smaller than that. It's 0.17 microns. So the virus can actually go through here, but luckily that virus just doesn't float in the air by itself. It's usually attached to a water particle, which gives it a much larger size than 0.3 microns. Bacteria can be blocked by this. Dust particles, some dust particles can make it through this type of filter, but a lot of them can't. Asbestos, people that work with this in removal of old installation in buildings wear different types of respirators to prevent the asbestos from getting into their own systems. So again, lots of different examples of filtration that can be observed and seen in the real world. We can also use a process known as evaporation. So evaporation is removing a solvent. So if you don't want to collect the solvent, let it evaporate and the solute would be left behind. So this is a good example of what we're going to be using in class when we try to separate a salt and sand mixture. We're going to dissolve the salt, get rid of the water because we don't really care about the water, get rid of it, and we'll be left with the salt. So evaporation is a very commonly used method to get a solute from a solution. Another one that you may not be familiar with is called centrifugation. So centri means center, fugate means to move to the outside. So this is a method that works by spinning a mixture around very rapidly. This is a picture of a centrifuge machine, and it works by separating the more dense materials, so density is the physical property, towards the bottom of the container. So we use centrifuge tubes. They're like test tubes with a little narrow point on the bottom that will separate the heavier, more dense materials towards the bottom. So one common example of this, if you ever had a blood transfusion, or people that donate blood will donate their blood and then they spin it in a centrifuge to separate the red blood cells from the rest of the blood serum so they can separate the fluids within your blood. Another example that I threw on here is, yeah, this is a washing machine. The reason it spins, it's separating the water from your clothes to make it easier to dry. So this is an example of a large centrifuge. There's lots of different industrial applications that use this as well. One of the labs that we do spend a little time on is called chromatography. You're going to see this during Science 9. You'll again see it in Biology 10 next year when you guys do some work with biological pigments. But it works on the fact that some materials are more soluble than others. So solubility is the physical property. And so when you put a substance into a solution, we know that some materials are soluble. So if we have a mixture of different solutes in a solution, we can separate them by putting them on a piece of paper, which is called chromatography paper. We can use a solvent. The solvent will actually migrate up the paper, and when it does that, the dissolved solutes will travel up the paper and be separated out at different distances from where they started. So couple examples, dyes. So the dyes that we have in our food. So if we were extracting red 40 from a M&M, let's say, we could take some of that dye, put it on a piece of paper, use a solvent, and we could watch it migrate up the paper and it would separate out. If we were to do this with plant pigments, we would see the same thing. In plants, there's different pigments that can separate based upon their solubility. Chlorophyll, xanthophyll, those are just some examples of pigments that could separate out. This is a picture of an example of how people use DNA, and they can separate DNA fragments based upon their solubility. So this is just an example of what's called gel electrophoresis, which is another example of chromatography. So this is just a snapshot of a lab that we end up doing in class where we put different dyes onto a piece of paper, and we'll be able to see what colors are found within that dye. Another very common example, this one is called distillation. So distillation can be done in a lot of different ways. So this shows the complete distillation apparatus like you might find in a high school laboratory where you're trying to extract a solvent from a solution. So instead of vaporizing the solvent, we want to heat it up. We're going to get it to its boiling point, and when it boils, we're going to try to keep it in this container right here, and then it's going to go through what's called a condenser, and we'll cool it off and it will form a liquid again. And so this works really well for separating mixtures. Here is your typical alcohol still. So back in the day, a lot of people started making moonshine and they developed their own little stills. So they would heat up the fluid in here, the liquid in here, and alcohol will vaporize at a much lower temperature than water. And so the alcohol would then go up through these coils. They would get cooled off, and as they would cool, they would start to condense and they would drip into this container, leaving behind just the ethanol. So that's just a very simple still when distillation is used. So again, if we were to do this, we would need to heat up our solution, but we need something to collect it. And so here's another common example of a simple distillation where you have your furnace on the bottom. It heats up some type of mixture that's a liquid, and we can heat it up to a certain temperature just to collect a designated vapor that we would like. We don't do this particular lab in class. It requires a lot of setup and a lot of time just to distill it. I'll set it up and show you what it looks like, but this is kind of how it works. You heat up the fluid, that solvent, get it to a certain temperature, and then it starts to condense into a liquid. It goes through this cooling condenser, and the liquid will be received over here in the receiving flask. So that's called distillation. So again, the solution is boiled, the steam is driven off, and then we can collect it. So if we wanted to collect the salt from a solution, the salt would be left behind, and the solvent would be collected over here. We would have pure water, and we would have the salt. This is not very effective if you were trying to make pure drinking water from ocean water, because it takes a lot of energy to do that. So that's why we don't have major plants along our oceans making fresh drinking water for us using salt water, because it takes a lot of energy to heat that water up to get it to boil. So when we do boil something off and we heat something up to its boiling point, we know that that's not a chemical change. So boiling something is a physical change. When salt water is distilled, we're simply heating the water up to its boiling point, vaporizing it, converting it into a gas, and we can ultimately collect the pure water and the salt. So it's just a nice separation method that we use very commonly to separate mixtures in a solution or to get that solute out. I'm going to skip over this. This is what we were working on in class as we did a salt and sand separation method. So first we filtered out the sand from the mixture. We were left with a saltwater solution, and then we have to go through that distillation process to get our pure water. Another common example is what's called fractional distillation. You just need to know distillation for this class, but fractional means that they can use different temperatures to remove lots of different substances from a mixture. So for instance, crude oil is what we pull from the earth, and we get all kinds of products from it. We can get gasoline for our car, we can get different types of chemicals, we can get different liquefied gases from there, jet fuel, so diesel fuel, different oils. So all of that can be pulled from crude oil by using fractional distillation. Another common method that's often used in class, and it's a quick, easy way to separate something by particle size and solubility, is simply by pouring off a liquid. So the liquid on the top is going to be very fluid. The sediment will settle out at the bottom. So a lot of times you can use a glass rod, or you can actually just pour the liquid right off into a beaker, and that's just a simple way to separate a solid from a liquid if they're mixed together, and that's called decanting. Another method is hand separation. This one works well, again, using your hands. So here's an image of people working at a recycling center. So all the commingled recycling comes in, and maybe they're sitting here watching things come through. They're looking for certain items that are metallic possibly. They'll pull them out. Or maybe there's certain types of plastic that come through here that shouldn't be in there, and they will pull them out and separate them. So again, hand separation is a commonly used separation method. We use this all the time. If you're eating a bag of Chex Mix and you don't like the rye chips, you're just going to grab the pretzels instead. Or maybe you prefer the rye chips and that's what you grab. So hand separation. So those are our different types of separation methods. One of the things that I would expect you to be able to do is list at least 7 different examples of physical and chemical properties. You should be able to describe the uses of these physical properties and how they can be used to help separate different types of mixtures. So that's what I have. Make sure that note outline is filled in. Be ready for a potential quiz on this in class in the next few days. Mr. Mechnick signing off.